Okay. Right, this is really important because I know that 37.5% of the exam is interpreting data, interpreting graphs, so it's equal to all the knowledge you need to know. So if you know this, you'll do really, really well. Right, and the best way I'm going to teach you this is by imagine a practical, and we'll talk our way through it. So let's imagine we're trying to find out what effect does temperature have on how quickly it takes for a sweet to dissolve in water. Okay, what effect does it actually have? So the temperature would be the independent variable. That's the thing that we change beforehand, and by changing the temperature, the time is affected. So the time is the dependent variable. It depends on what you did to the independent variable. Now there are other types of variables called control variables. These are variables that you keep the same in order to make sure it is a fair test. So a control variable, you're going to keep the amount of water the same, you're going to keep the amount of stirring the same, and you're going to use the same shape of container. I'm going to drill down a little bit here because obviously the amount of water, you could have 1 milliliter, 2 milliliters, 3 milliliters, 4 milliliters, you could have any number you wanted to, and that is known as a continuous variable. Okay, now the shape of container, it only comes in, shall we say, 3 or 4 sizes, shapes. So it's a beaker, a bowl, or a glass. Now those are categories. It's a beaker, a bowl, or glass. There's only 3 or 4 choices. So that is an example of a categoric variable where you only have 3 or 4 sizes, different quantities, or perhaps even 9 or 10 quantities. For example, a good example of categories would be hair color. It could be eye color. It could be shoe size. They only come in certain shapes. So categoric variables have certain values, continuous have loads and loads of values. Here's the data we collected. You might want to have a look at this first to see what's going on, and when you can see exactly what the pattern is there, we're going to discuss about what exactly is relevant about the green symbol. So you might want to pause it for a second. The green one number there is an anomalous result, and an anomalous result is a result that does not fit the pattern. You might want to make that into a revision card. So not what is an anomalous result, it's one that does not fit the pattern. What do you do with it? You discard it. You don't include it in your calculations there for the average, and that's exactly what I've done. And you can plot this in the form, plot those data in the form of a graph. You can see quite clearly there, as you increase the temperature, the time taken to dissolve gets less. I thought at this point it'd be quite useful to show you an important concept. In the previous chart, you had 2 continuous variables, and if you've got 2 continuous variables, you can plot a line graph. If, however, one of the variables is categoric, you can only plot a bar chart. Okay, so that is a very common question. Why can you display this as a bar chart? Because the data is categoric. Okay, so the data is categoric. The other question is, when can you plot a line chart? When both sets of data are continuous. Right, there's an awful lot of terms I need to go through now, and for most of the time I'm just going to be zooming into the data, but you can copy down all the answers to the side there. So let's first of all, let's have a look at the first thing we need to consider, which is zero error. A zero error is basically when you start to measure something and there's already an error on it before you've even started. That is a zero error. So for example, you might have a meter that when there's no supply to it is already reading 0.2 volts. Well, that is a zero error of 0.2 volts. In the science lab, you probably had your teacher talking about don't tap the meter rules down because the end gets worn away. So some rulers have lost 1 or 2 millimeters from the end, and those are zero errors when a reading is showing when there shouldn't be a reading. Okay, and what you have to do with that is take that value off every single reading that you do. A fair test is basically a experiment where only one variable has been allowed to change, and that is the independent variable, and it allows you to test the hypothesis. Now the reason I'm saying this is that very often they'll ask you a question, why have they only changed one variable? And students write down, not to make it a fair test. They are not giving you marks for that. You need to say, by changing one variable, it allows you to test the hypothesis. It allows you to see if changing that independent variable does affect the dependent variable. So be careful in using the word fair test in any of your answers. It'd be better to say it allows you to test the hypothesis that changing the independent variable has an effect. Right, we're now going to look at each of these terms one at a time. Accuracy. What does accuracy mean? Accuracy means how close to the real value or the true value your reading is. Calibration means making a scale on a measuring instrument. So for example, the thermometer, the way you put the scale on that is you put the thermometer in, which has got no markings on it, into melting ice, and you know that's 0 degrees C. Then you put the thermometer in boiling water, and you know that's 100 degrees C. And then you divide that thermometer into 100 pieces, and those are degrees centigrade. Errors and uncertainty refers to the difference between the true value and your measurement. Whatever you say, don't say errors are mistakes. In science, they're not. It's basically saying how close to the true value are you, do you think, with that? And it's going to be slight changes. What causes uncertainties and errors? Some of them is random. They're unpredictable. So, for example, if I asked 5 of you to time how long it takes for someone to run a certain distance, 5 of you may time slightly different times, and those are known as random errors. The way you get rid of random errors is by taking repeats, and that reduces random errors. Systematic errors is when through your use of technique, use of equipment, or your procedure, you are always bringing in an error of the same amount. So a zero error is a good example of that. So when you're always systematically or always off the true value by the same amount. The next one we need to know about is, what do we mean by interval? Right, an interval in this case is 10 degrees. So for example, you see the temperature was going from 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees. The interval in the temperature is 10 degrees, how much it steps up by each time. When they say, what do we mean by precision? Precision means how much spread is there in the data. So if you look at the 10 degree column, you can see it says 75, 77, 79. That's fairly precise. Look at the 50 degree line. If you notice, that's 12, 13, 12. That's very precise. There's very little spread around this. So that's a very precise reading, whereas 10 degrees has got a bit more spread in it, and certainly the 30 degree ones has got a massive spread in the data, or there's very little precision there. The range in this case for temperature is from 10 to 50 degrees. So you could say range is from 10 to 50 or 40 degrees C, because obviously 50 take away 10 is 40. Right, the next one we need to look at is, what do we mean by repeatable and reproducible? Repeatable is if you get the same results, if you yourself get the same results by using the same experiment, using the same method. Reproducible is if someone else get the same results as you by using, they could use the same method, or they may use a different method, but they still get the same results. So that's the difference between repeatable and reproducible. Resolution is, what is the smallest detectable change in the instrument? So in this experiment, we're talking about time. Well, probably the smallest time you could probably get in that would be like 0.01 of a second if you were using a stopwatch. So that would be a resolution of 0.01 for the stopwatch. For the thermometer, it's likely to be 1 degree C is the difference you can detect, smallest change detectable. Valid. Is the experiment valid? Well, an experiment's valid if your conclusion is supported by the data in front of you. So if you're in our graph, it seems quite clear. As the temperature increases, the time taken to dissolve reduces. You can see the data supports that, and then we'd have to make sure that the experiment's been done correctly. Has it been a fair test? Have you kept the controls the same? Did you only change one variable? And if you have got a fair test, then and your data does support a good conclusion, then that experiment is valid. So there's an awful lot there, but it really is worth knowing these terms because they come up in every exam. And in AQA, for example, and if you're doing triple science, that is 9 exams you'll face with this sort of information being asked of you. So this is why I say it's the most important video to know.